Dubbed as the project of the century, the Metro Manila subway, designated as MRT Line 9, is an under-construction underground rapid transit line in Metro Manila, Philippines. The 36-kilometer line, which will run north to south between cities of Quezon, Pasig, Makati, Taguig, and Pasay. The first alignment consists of 17 stations from the Quirino Highway in Quezon City to FTI Integrated Terminal in Taguig City. Future plan includes the extension to Bulacan in the north and to Cavite in south. It will become the country's second direct airport rail link after the North-South Commuter Railway, with a spur line to Ninoy Aquino International Airport. It will be also well connected to the existing and future urban rail system in Metro Manila. Riders may transfer to LRT Line 1, MRT Line 3, and MRT Line 7 at the North Avenue Common Station. Other connections include the existing LRT Line 2 and PNR Metro commuter line, as well as the planned Makati Intra-City Subway, the MRT Line 4, and MRT Line 8. The partial operability of first phase of the project, which is 4 stations from East Valenzuela to North Avenue, is already under construction and expected to be up and running by early 2022, with the rest of the subway scheduled to become operational by 2026. On December 22, the transport agency announced that it had ordered a total of 240 train cars for the upcoming Metro Manila subway. Following a contract package signing between the Philippine government and the Sumitomo Corporation and the Japan Transport Engineering Company joint venture, DOTR ensured that building the subway would be safe, citing the Japanese technology to be employed. Engineers and consultant involved in the construction of the Metro Manila subway were also the engineers and consultants in Japan subways, where typhoons and earthquakes happen most often. This means that they have their talent, skills, and experience that will be used for this construction. The train cars will be manufactured by J-Trek, the leading car train manufacturer in Japan, which also supplies car trains in the United States. Metro Manila Subway will use one Sistina product brand name for the next generation stainless steel train cars, featuring higher energy conservation, enhanced safety and high maintainability, have been adopted by multiple railway lines including the Yamanote line operated by East Japan Railway Company. The deal has a total approved cost of 367 billion pesos for the design, supply, installation, construction, testing, and commissioning of train sets for the subway line. That's for 240 train cars or for the 30 trains by 8-car train set. The proposal to create the first ever subway line in the capital region dates back to September 1973, when it was first proposed under the Urban Transport Study in Manila Metropolitan Area, conducted by the Japan Overseas Technical Cooperation Agency, a predecessor of JICA. The subway was then proposed in 2000 during the administration of Estrada, and 2014 during the term of Aquino. None of the proposal were approved. In 2017, the current administration completed the detailed feasibility study for the Metro Manila subway, which immediately obtained NEDA board approval in September 2017. On March 2018, the loan agreement was signed between President Rodrigo Duterte and Japanese Prime Minister Shinzo Abe. The 367 billion peso project is eyed to be completed in 2025. Some 85% of the cost was loaned from Japan, expected to be paid in up to 40 years, with a 12-year grace period and 0.1% interest. The partial operability of first phase of the project, which is 4 stations from East Valenzuela to North Avenue, is already under construction and expected to be up and running by 2022, with the rest of the subway scheduled to become operational by 2026. It will serve 370,000 passengers daily in its first year. All stations will be fully operational by 2026, with a design capacity of 1.5 million passengers per day. As Philippines is inching closer towards having its first subway system, the Department of Transportation, DOTR, unveiled on February 2021 a part of a tunnel boring machine. The head cutter, that is crucial to fast-track the construction of the Metro Manila subway. While on April 2021, 2 of the 25 tunnel boring machines needed for the Metro Manila subway project had arrived in the country. The cutter head is the largest part of the tunnel boring machine, weighing 74 tons or as heavy as 2 Airbus A320 airplanes. Its main purpose is to break, cut and grind rocks and soil, with the power of 300 jackhammers by rotating its 36-piece disc cutter. The machine can dig up to 6 to 12 meters a day. Remaining TBMs could arrive in the country in the coming days. One of the most popular construction methods used by tunnel boring machines or TBM, is EPB. Underground TBM is constantly subject to static earth pressure and water pressure. To even out balance them, trussed jack cylinder applied forward pressure. The earth pressure balance is managed with earth pressure gauge. The ground is excavated by the cutter head and broken up. Additive injected is softened and adjusted, so it can be more easily convey pressure to the earth pressure gauge. Pressure bounce is maintained while excavating, and soil is evacuated using the screw conveyor. TBMs thereby bounces static earth and water pressure to smoothly and stably performed excavation. TBMs, such as EPB machine, are composed of shield body which perform tunnel excavation, and a backup system, which carry the equipment necessary for the excavation. The cutter head rotates, excavating the soil in front of the TBM. The cutter head is equipped with this cutter, and scraper bit. This can be replaced when it became worn out. The bearing is rotated by the cutter motors, turning the cutter head at the front of the TBM. Thrust jack cylinders are extended to pushes some form segments, and the counter forces pushes the TBMs forwards. The TBM is equipped with an articulation jack system from negotiating sharp curves. The cutter's head is composed of front and rear shield, and articulation enables them to excavate these curves. The erector holds each segment to reach strokes, assembling these segments in ranges. The erector places each segment in place individually, and then places the key segment, completing the ring. The TBM uses a symmetric straggler joint construction. The embedded pumps in the back of cars pump a liquid and B-liquid to the grouting units mounted in the machine. 2 grouting units for grouts between segments and the skin plates, while the TBM performs excavation. These prevents subsidence and water leakage from between segment, and as well as rapidly stabilizing the segments. The additive pumps in back, while the cars pumps foams and polymer to the cutter head. Additive is injected by the cutter head, while machine excavation is on progress, solidifying the muds. The screw conveyor excavated soil to the rear of the TBM. The soil is passed through a rubber hose, to the backup of conveyor through the tunnel conveyor, to final conveyor. In that order, and carry to the rear of the tunnel. The use of tunnel conveyor is far more efficient than excavations, by Mack cars. The rolling stocks supply new segments. The strolling stock is made of locomotives, 2-segment cars and a platform. A crane picks up individual segment brought in from the back up and load them one by one to the erector. These giant machines are 2 of the 25 total tunnel boring machines, on which 6 TBMs will be used for the partial operability section of the subway project, that will be used to dig the tunnels and passageways for the whole subway line from Valenzuela through Quezon City, Pasig, Taguig and the Ninoy Aquino International Airport in Pasay.